I am Greg Talata, and I will be presenting on AI recognitions of birds of Alaska. To be exact, I will be recognizing ravens and puffins. So my original plan was to, given a picture of a single bird taken from any angle where it takes up most of the pictures, detect whether it contains a puffin or a raven. And then I also plan to use the data set that was shown in class. So what's happened is I started out with doing research and learning Python because I didn't know Python super well. I also obtained a copy of Deep Learning with Python, the book that was also shown in class. And here it is, Deep Learning with Python. So I based my implementation on examples in it, and I think it's an excellent book for learning Python and deep learning in Python. It's good for both. So the data set I used was the one that was shown in class, like I mentioned earlier. It was originally not very organized well. I did not understand the organization. It was just a whole bunch of numbers, and they didn't correlate with the number of pictures in the files to begin with. So, not too sure what was going on there. I ended up writing a Python script to rename it and then sort the data. So the important numbers are that I had 751 photos of ravens and 1,000 plus photos of puffins. Because of that, I used 751 of each, and then I divided that by 4 to get my per section, and then I used 2 sections for the train, 1 section for validation, 1 section for test, which ended with 374 of each type of animal for the train, 187 for validation, and 186 for each test. So this was how the data was originally stored. Ignore this. This was something I created with a script, but I had a couple folders for each animal, and then inside it was just them named. And originally it just had numbers like this. The last one I changed the names to be what I wanted. And this is what matches the cats and dogs in the book, which allowed me to stick them all together in one folder so that I could then use a modified version of a script from the book to create my testing data, which is over here. So ignore failed. We'll come back to that later. So the test, we got some amount in test. In train, we've got the 300 or so in train. Yep. And that's the organization, which I used this script to rename all the files, and then I copied them over to the other folder where they were all together with this file, with this script, and then I used this make data, which is edited from Deep Learning with Python. So I am running on Windows, and the book recommends dual booting to Ubuntu to run TensorFlow and just install it on a Linux installation. I really didn't want to do that. I have not had success with trying to dual boot stuff in the past. So I tried a bunch of different ways to get TensorFlow and Chaos to run on Windows. A lot. And I ended up finding a guide from a professor at the University of Washington of how to run TensorFlow in a mini Conda virtual environment, but not have it get GPU acceleration. He had another guide on GPU acceleration. However, at that point, I didn't really have enough time left to try to set that up. So now we're going to move on to training and modifying the model. So I did get it to finally work, as I mentioned. I based it on cats and dogs from Deep Learning with Python. I had to do minor edits to it, like change function calls to newer versions, and the reason I was able to do that is because I formatted my data to be organized the same way. So in the first attempt, with no runtime errors, there was no validation data saved. The training results were promising, however. They looked to be correct. In the second attempt, I correctly saved the validation data. The training accuracy is between 96 and 100%, and the validation accuracy was around 87%, which was higher than I was expecting. In my third attempt, I changed the code to use all new function calls from with inside of KS instead of the older calls that are going to be removed shortly. The training data was still between 96 and 100%, but the validation accuracy was ever so slightly higher. It might have just been a fluke of running it again, it not having to do with calling a different function. So then I switched to using augmented data. That means I created more training images by distorting the images I already had. This helps with confirmation bias, where you get stuck on one thing all the time, and you fit yourself to your trained data, basically. The training accuracy was between 83 and 90%, and the validation accuracy was between 90 to 92%. So this shows that confirmation bias was a large problem in previous attempts, and because the validation accuracy is higher than the train accuracy, it shows that more epochs are definitely needed. So epochs are the amount of times that you loop over training. It's a short summary of what epochs are. So what I did next was I ran the augmented with 100 epochs instead of 30. I was previously doing it with 30, so 100's a lot more. The validation accuracy increased to 94 to 95%, and the train accuracy was 93 to 95. So they're pretty close. This is close enough where doing more epochs might help, but it might not help. I did then run the non-augmented version again, so the same as in attempt 3, except changed it to use 100 epochs instead of 30. The validation accuracy was 86 to 87, and the train accuracy was 99 to 100. So that was a slight, very slight increase. So then I used the model to predict images. So that means I fed it an image, and it told me whether it was a raven or a puffin. So this is the script I wrote to test all the images. I kind of did it individually. You're supposed to create a batch and then feed the batch through model predict. However, it just kept throwing errors at me, and I was able to run it on a single image. So I just created 2 for loops for each test directory of the type of animal. And because I was using a bunch of predefined stuff, I didn't have titles for any of the animals. So 0 is puffin. No. Yes, 0 is puffin and 1 is raven. So if they didn't work, I told it go copy the image over to a fail directory, which I will show you now. So these are all the ones that it failed on guessing, and for the puffins, it failed on a lot less puffins than ravens. But for the puffins, it did fail on. It's mostly images from the back, which makes sense because they have a black back and ravens are mostly black, so it makes a bit of sense. And then I noticed that a few are flying, which is interesting. And then if we come over to the ravens, it just kind of seems like random raven images until you start looking really closely. So a lot of them are flying. That's our first clue. And then a lot of them have either gray or blue backgrounds. I think this is because most of the puffin images are either on the water, on a cliff, or in the air. So when they're flying in the air or on the water, depending on if the light's glinting off, it's a very similar gray color. And blue is water, yeah. and then like this raven, it's all tan around it, which a lot of the puffins are sitting on tan cliffs. So maybe that has something to do with it. And like this one has light glinting off its back, and this one has light glinting off its wings that are making it look more light gray or whitish. So that might be doing it. It's just interesting that it failed on a lot more ravens than it did puffin. Here are my sources.